Hi everyone, welcome to lecture 12 on basic inorganic chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover formulas of ionic compounds. We will look at naming of binary ionic compounds and ternary compounds. So we now look at how to write formulas of ionic compounds. Formulas of ionic compounds are determined from the charges on the ions. Let's look at this example. So here we have sodium with 1 electron in its outermost shell. And this is fluorine with 7 electrons in its outermost shell. So fluorine needs 1 electron to complete the octet arrangement. So here, sodium is positively charged because it has given its 1 electron to fluorine that needs that 1 electron. So fluorine is then negatively charged because it has received 1 electron. So sodium, positive charge, fluorine, negative charge. Positive and negative cancel out. The overall charge is 0. So this is how we arrived at NaF being a neutral compound. As you can see here, positive and negative charges cancel out. We now look at how to write formulas of different ionic compounds. If you are asked to write the formula for the ionic compound that will form between barium 2 plus and Cl minus, the first thing you do is that you need to balance the charge for positive and negative ions. The second thing you do is to write the positive ion of metal first, and then write the negative ion. So in this case, we write barium 2 plus first, and then we write chloride ion. So because barium has 2 plus charge, we need 2 chloride ion to balance it. That's why we wrote another chloride ion. So in this way, 2 plus and 2 minus will cancel out. So the last thing you then do is to write the number of ions needed as subscripts, and do not include any charge from both the positive and negative ions. So you write the number of ions needed as subscripts. So we have barium 2 plus. We don't write charges, as I said here. So you don't need to write either positive or negative sign. So here we use 2 chloride ions. So we write 2 as subscript. So that's how we arrived at this formula for barium chloride. So it is BaCl2. Let's look at more examples. If you are asked to write the correct formula for the compound that contain Na plus and S2 minus, first you balance the charge for positive and negative ions. So we have Na plus and we have S2 minus. So we need 2 positive to balance 2 negative. So 2Na because S has 2 negative charge and sodium has +1 charge. So the next thing you then do is to write the positive ion of metal first and then the negative ion. So we write the positive ion of metal first. So we write Na plus because we need 2 Na plus to balance 1 S2 minus. We write Na plus twice and then we write the negative ion. So in this way, 2 positive, 2 negative will cancel each other and the overall charge will be 0. So the next thing is to write the number of ions needed as subscripts and do not include any charge from both the positive and negative ions. So we need two Na plus to balance S2 minus. So then the formula is Na2S. So these two, because we needed two Na plus to balance S2 minus. So this is the formula, Na2S. Let's look at another example. If you're asked to write the correct formula for the compound that contains Al3 plus and Cl minus. So first, you balance the charge for positive and negative ions. So 3Cl, we need 3Cl because aluminium has +3 charge and chlorine has -1 charge. So to balance, you need 3Cl minus to balance aluminium 3 plus. So the next thing you do, you write the positive ion of metal first, followed by the negative ion. So positive is aluminium 3 plus. Because we need 3Cl minus to balance aluminium 3 plus, we write 3Cl minus. So 3Cl minus Al3 plus. So 3 plus, 3 minus will cancel each other. So the next thing is to write the total number of ions needed to balance the charge as subscripts. And again, do not include any charge from both the positive and negative ions. We need 3Cl minus to balance Al3 plus. So the formula is then AlCl3. So this 3, because we needed 3Cl minus to balance Al3 plus. So let's look at another example. If you are asked to write the correct formula for the compound that contains Mg2 plus and N3 minus. So first, we balance the charge for positive and negative ions. A way to balance the charge is to have 3 Mg2 plus and 2 N3 minus. So what it means is that we will have 3 Mg2 plus, which is equals to 6 plus for the charge, and 2 N3 minus is equal to 6 minus. So in that way, the overall charge will be 0. So we have balanced the charges. So the next thing is to write the positive ion of metal first and the negative ion. So we write the positive ion of the metal first. Because we need 3, we write it 3 times. And because we need the negative ion twice, we write it 2 times. So in this way, the charges are balanced. So the last thing to do is to write the total number of ions needed to balance the charge as subscripts. And again, do not include any charge from both the positive and negative ions. So 3 Mg2 plus is needed to balance 2 N3 minus. So then the formula is Mg3 because we needed 3 of it, and N2 because we needed 2 of it. So the formula is Mg3N2. Now we look at naming of binary compounds. A binary compound contains two different elements. Example is sodium chloride, which contains sodium and chlorine. To name a binary compound, you name first the metal, then the non-metal, you end the name as IDE. So examples, NaCl is named as sodium chloride. So you name the metal, which is sodium first, and the non-metal, you end the name with IDE. Zni2 is zinc iodide. We name the metal first, and the last element, which is a non-metal, we end the name with IDE. Al2O3 is aluminium oxide. So always we name the metal first, and then the last element, which is a non-metal, we end the name with IDE. So let's have a look on these examples. Complete the names of the following binary compounds. So Na3N is sodium nitride. So we started with the metal, we named the metal, and we ended the non-metal with IDE. KBr is potassium bromide. Started with the metal, potassium, and the non-metal, we ended it with IDE. Al2O3 is aluminium oxide. Mgs is magnesium sulfide. We started with the metal, which is magnesium. We named it first, and we ended the non-metal name with IDE. Right. We now look at naming of polyatomic ions. What is a polyatomic ion? A polyatomic ion is a group of atoms with an overall charge. They do not have an overall zero charge. Let's have a look on these examples. NH4 plus is ammonium, NO3 minus is nitrate, HCO3 minus is hydrogen carbonate or bicarbonate. OH minus is hydroxide, NO2 minus is nitrite. We now look at more examples on naming of polyatomic ions. SO42 minus is sulfate, SO32 minus is sulfite. So notice the difference between these two. When it is O3 is sulfite, O4 is sulfate. HSO4 minus is hydrogen sulfate, HSO3 minus is hydrogen sulfite. So always when there are three atoms of oxygen is ITA. It ends with ITA, but when there are four, it ends with ATA. PO43 minus is phosphate. H2PO4 minus is dihydrogen phosphate. Right. We now look at naming of ternary compounds. What is a ternary compound? A ternary compound contains at least three different elements. To name a ternary compound, you name the metal first and then name the non-metals as a polyatomic ion. Let's have a look at some examples. NaNO3, you first name the metal, which is sodium, and the last part, you name all of them as a polyatomic ion. The last part, which are all non-metals, you name all of them as a polyatomic ion. So the name of NaNO3 is sodium nitrate. K2SO4, you name potassium first, which is the metal. The remaining parts, which are all non-metals, you name them as a polyatomic ion. So the name is potassium sulfate. So the same thing is applicable for this compound as well. Right, let's look at some practice examples. What is the correct name of each? Na2CO3. The correct name is sodium carbonate. So first you name the metal, which is sodium, and you name the non-metals as a polyatomic ion. So the name is sodium carbonate. MgSO3 is magnesium sulfite. MgSO4 is magnesium sulfate. So first, you name the metal, and the remaining parts, which are all non-metals, you name them as a polyatomic ion. What is the chemical name for this? The chemical name for this compound is calcium bicarbonate. The chemical name for CaCO3 is calcium carbonate. And the chemical name for this compound is calcium phosphate. Right, let's look at transition metals. Transition metals are located at the middle of the periodic table. They can form many positive ions. They form colored compounds and act as catalysts. So these are examples of transition metals. You can see that most can form many positive ions. Vanadium can form +1, +2, +3, +4, and +5. Chromium can form +1, +2, +3, +4, +5, +6. Manganese can form +1, +2, +3, +4, +5, +6, and +7. So most transition metals can form many positive ions. Right, we now look at names of variable ions. To name variable ions, you use a Roman number after the name of the transition metal. So here FeCl3, the transition metal is iron. So the name will be iron trichloride. So you use a Roman number after the name of the transition metal. So we use 3 because there are 3 chlorine atoms. So CuCl is copper 1 chloride because copper is the transition metal. SnF4 is tin 4 fluoride. Tin is the transition metal. PbCl2 is lead 2 chloride. Lead is the transition metal. So this is how to name variable ions. Let's look at some practice examples. What is the formula for the ionic compound of K plus and S2 minus? The correct answer is K2S. S2 minus, and there is only here 1 positive. So it needs 2 positive to balance 2 negative. That's why we have K2S. The formula of a compound of magnesium and bromine is MgBr2. The reason is because Mg has 2 plus, so it will need 2 negative to balance the charge. So it will be MgBr2. The formula of copper 2 plus and Cl minus is CuCl2. Copper has 2 plus, chlorine just 1, so it needs 2 Cl minus to balance it. So that's why we have 2 here. So this is where I'm gonna end today's lecture. Please like this video and subscribe, and I will see you in the next lecture.